Imagine you're sending a letter. You need the recipient's address to ensure it reaches the right person. Similarly, computers on the internet need addresses to communicate with each other. These addresses are called IP addresses. IP stands for Internet Protocol. Every device connected to a network has a unique IP address. This address allows devices to send and receive data packets across the internet. Think of an IP address as a phone number for your computer or smartphone. Just like you use phone numbers to call someone, websites and applications use IP addresses to connect to your device. Without IP addresses, communication over the internet would be impossible. It's like trying to send a letter without an address. It would never reach its destination. IP addresses are crucial for internet communication. They enable devices to identify and connect with each other. Without them, the internet as we know it would not exist. When you type a website address into your browser, your computer uses a system called DNS, Domain Name System, to translate the website name into its corresponding IP address. This address tells your computer where to send the request to access the website's content. IP addresses also play a vital role in network management. Network administrators use them to configure networks, assign addresses to devices, and troubleshoot connectivity issues. Moreover, IP addresses are used for security purposes. Firewalls, for example, use IP addresses to block unwanted traffic and protect networks from unauthorized access. In essence, IP addresses are the foundation of internet communication. They provide a unique identifier for every device on the network, enabling seamless data exchange and facilitating various online activities. There are two main types of IP addresses: static and dynamic. Static IP addresses are permanent and manually assigned. Dynamic IP addresses are assigned automatically by a DHCP server. Static IPs are reliable for consistent access. Dynamic IPs offer flexibility and ease of connection. IPv4, or Internet Protocol version 4, is the most widely used IP address version. It has been the standard for decades and is still used by most devices on the internet today. An IPv4 address consists of 4 numbers separated by dots, ranging from 0 to 255. For example, 192.168.1.1 is a typical IPv4 address. Each number represents 8 bits of data, making a total of 32 bits for the entire address. With 32 bits, IPv4 can accommodate around 4.3 billion unique addresses. While this seemed like a vast number initially, the rapid growth of the internet and the proliferation of internet-connected devices have led to concerns about IPv4 address exhaustion. To address this issue, various techniques, such as NAT or Network Address Translation, have been implemented to extend the lifespan of IPv4. However, these techniques are merely temporary solutions. The long-term solution lies in the adoption of a newer IP address version, IPv6. Section 5. Limitations of IPv4. IPv4 has several limitations that have become apparent with the growth of the internet. The most significant limitation is its limited address space. With only 4.3 billion addresses, IPv4 cannot accommodate today's billions of devices. Another limitation is its lack of built-in security features. IPv4's complex addressing scheme can lead to configuration errors. IPv6 addresses these limitations with a larger address space and enhanced security. Section 6. Introducing IPv6. IPv6, or Internet Protocol version 6, is the latest version of the Internet Protocol, designed to address the limitations of IPv4 and accommodate the ever-growing number of internet-connected devices. Unlike IPv4's 32-bit address space, IPv6 uses a massive 128-bit address space. This allows for an astronomical number of unique IP addresses, effectively eliminating the issue of address exhaustion. To put this into perspective, IPv6 can provide enough addresses for every grain of sand on Earth. IPv6 addresses are represented in hexadecimal notation, consisting of 8 groups of 4 hexadecimal digits separated by colons. For example, 2001 0DB8 85A3 00Z 882E 0370 73334. While this might seem more complex than IPv4's dotted decimal notation, it allows for a more efficient and manageable addressing scheme. IPv6 comes with built-in security features, including IPsec, which provides encryption and authentication for data packets. This enhances the security of internet communications and protects against various security threats. Furthermore, IPv6 simplifies network configuration and management. Its auto-configuration capabilities allow devices to obtain IP addresses automatically without manual intervention, making it easier to connect new devices to the network. Section 7. Advantages of IPv6 over IPv4. IPv6 offers significant advantages over IPv4, making it the future of internet communication. The most significant advantage of IPv6 is its vast address space. With 128 bits compared to IPv4's 32 bits, IPv6 can accommodate trillions of unique IP addresses. IPv6's built-in security features, including IPsec, provide enhanced security for internet communications. Moreover, IPv6 simplifies network configuration and management. IPv6 supports mobile IP, allowing devices to move seamlessly between networks. IPv6 offers improved performance and efficiency compared to IPv4. Section 8. Examples of IPv4 and IPv6 addresses. To illustrate the differences between IPv4 and IPv6 addresses, let's look at some examples. 2001 0DB8 85A3 0000 8A2E 0370 7334. As you can see, IPv4 addresses are shorter and use dotted decimal notation, while IPv6 addresses are longer and use hexadecimal notation. The difference in length reflects the vast difference in address space between the two versions. Section 9. The future of IP addresses. The future of IP addresses undoubtedly lies with IPv6. While IPv4 will continue to be used for some time, its limitations are becoming increasingly apparent, and the transition to IPv6 is inevitable. Many organizations and internet service providers, ISPs, have already adopted IPv6, and the number of IPv6-enabled devices is steadily increasing. Major operating systems, such as Windows, macOS, iOS, and Android, have native support for IPv6, making it easier for devices to connect to IPv6 networks. The transition to IPv6 is a gradual process, and both IPv4 and IPv6 will likely coexist for many years to come. However, the long-term benefits of IPv6, such as its vast address space, enhanced security, and improved performance, make it the obvious choice for the future of internet communication. As the internet continues to evolve and new technologies emerge, IPv6 will provide the foundation for a more connected, secure, and efficient online experience. Section 10. Conclusion. IPv4 versus IPv6 and the importance of IP understanding. In conclusion, IP addresses are essential for internet communication, acting as unique identifiers for devices on the network. While IPv4 has been the standard for decades, its limitations have led to the development and adoption of IPv6. IPv6, with its larger address space, enhanced security features, and simplified addressing scheme addresses the shortcomings of IPv4 and paves the way for the Internet's continued growth. Understanding the differences between IPv4 and IPv6 is crucial in today's digital landscape. As the transition to IPv6 continues, familiarity with both versions will become increasingly important for individuals and organizations alike. By embracing IPv6 and its advantages, we can ensure a more robust, secure, and efficient Internet for the future.